My name is Matt Bloomberg. I'm a product manager on the cloud team focused on API security. And I'll be joined today by Joel Disa, who's a security tech lead on the API security team at Appaji as well. And we're here to talk about APIs and how to design the right architecture to ensure that your data and users' information can remain secure. So I'm going to start with an overview of the power of APIs, what impact it's had on businesses to date, a little bit of the history there. I'll explain why visibility of your APIs is important and what can happen if you don't have that visibility. And then Joel's going to cover everything from what the most common threats that we are seeing in this space today, how architecture needs to evolve from how it was in the past to how it currently is shifting with microservices and current future trends, and best practices on how to secure your APIs. If you have the Cloud Next app, you can submit some questions there, and we're happy to answer them at the end if we have time. It's a very tight schedule today. You also can step up to the mic and ask questions, so either works. You can also come up to us after the session, no problem. So APIs are powering innovation, and just to start with a little bit of the history there, APIs have been around for about 20 years, and they were created out of a need. In the early 2000s, APIs were first used by companies like Amazon and eBay, who were noticing unofficial usage of their services and data. These companies needed a way to provide structure to their developers, their partners, and their customers in a secure way and scalable way. And now APIs are everywhere, and they're a key enabler to innovation because they're facilitating new ways for customers and partners to interact with each other. They're also enabling new use cases by connecting legacy infrastructure to modern web apps and mobile apps. APIs can also enable use cases such as voice ordering from a phone to connecting brick and mortar companies, moving them into an e-commerce future, and connecting partners and services. So an example here talk about Walgreens for a minute. They have thousands of locations, and they're leveraging, just to mention a couple of their APIs, they have a store locator API. And Fitbit is actually using that to enable Fitbit customers to easily locate a Walgreens location and use Fitbit Pay to actually pay in the store. So there's a couple different APIs being used there. They also have a photo printing API, and this enables third-party apps to print to a Walgreens location and pick up photos in the store. So this is driving customers and traffic to a retail location and enabling third-party app developers to have a rev share model with Walgreens. So it's a good win-win situation there, but driving more customers to the stores. If we take a look at Magazine Luiza, this is one of Brazil's largest retailers. They've been around for more than 60 years. They realized that it's not only about physical brick and mortar anymore. They wanted to move into the e-commerce space. And APIs have enabled them to scale to thousands of delivery partners and increase their product catalog from going from 50,000 products to 1.5 million products. So they had a 30x increase in the number of products by enabling 2,000 merchants to support and sell their products on their e-commerce platform. And as you can see here, the financial impact has been incredible. So what we're seeing trends from customers, in many cases, security is an afterthought. It's how do we design what are the problems we want to solve, what's the customer requirements, and how do we build that? And security is kind of one more thing they need to deal with. And in many cases, it's an afterthought, and that puts a lot of production user and data at risk. So a lot of the data that's exposed today, we're talking payment information, PII, PHI, banking information. If you don't have the proper visibility into what is exposed and how it's exposed, you're creating a lot of risk and liability. And this is why having a full lifecycle API management solution is really needed to enable a secure way of enabling the exposure of this information. So just to give a high-level overview of what Appaji is offering, Appaji is an API management platform, and it breaks it into kind of three components here. From a developer management perspective, we are providing a secure way for developers to scale their APIs to a larger audience and consume the information in a managed way. We're offering API analytics, which gives you clear insights to measure, tune, and monitor your API program. And I'll dive in a little bit more about the API monitoring in a few minutes. And API services give you complete control by allowing you to manage the connection between the API consumer and the back-end infrastructure and service. So you can have complete control over the request and the response. So just to give an example from Google Maps, if you search for a hotel for this week, you can now choose dates that you want to check into a room. You see the availability of that room, and you can actually get live pricing data in Google Maps, because this is being powered by APIs from these third parties. And this now allows you to book directly in the mobile app or the web app, and or through thousands of travel partners. So, Zen Hotels, Kayak, all of these guys have a relationship with the St. Regis. So this is just a quick example of how powerful APIs can be, as opposed to the old world of manually updating pricing across different sites, and when something is sold out, the time it takes to remove those listings. So this has been very powerful in Google Maps and search. But discussing Walgreens, Magazine Luiza, and Google Maps, these are a few examples where APIs have been powering business innovation and disruption in different markets. But in some cases, disruption is not always a good thing. And when security is an afterthought, sometimes enterprises don't take the right precautions before exposing their APIs and services. And in many cases, it's simply a lack of awareness of what's exposed, what controls are in place, and what is actually happening with the data. So just to talk a minute about the USPS, and there's no shortage of these examples, so I'm just going to kind of highlight this one. And they offer a new service for their customers called Informed Visibility, and this allows businesses and users to gain the ability to track near real-time tracking for mail campaigns. So the issue they had really kind of breaks into two parts. They misconfigured their API and allowed wildcard input, which Joel will talk a little bit more about input validation, but that was not the right way to do it. And they also had no visibility into what data was exposed or who's accessing that data. So the configuration that they deployed allowed any user to view or change any other user's information, such as the email address, phone number, and other PII. And this is far more harmful than a single user's account being compromised. If someone hacks into a single user's account, they have all of their data, and that's obviously not a good thing. But in this case, 60 million users' data was exposed for several months. And this could have been avoided if they used proper OAuth scopes and simply didn't allow access to other users' data, or, as Joel will talk about later, input validation, where they simply should not have allowed wildcard input to prevent multiple records from being extracted. And you won't always be able to prevent every misconfiguration. People are human, but there are a lot of processes and methods you can take in an approach to ensure that these kinds of things don't happen. And again, Joel's going to talk a little bit more about that. But this is another example of why having visibility into who's accessing your data is extremely important. So it's just happening too often. So there's an article from Dark Reading. In the first 9 months of last year, there were 3,600 reported breaches. So this isn't just about the Postal Service. And the fourth largest data breach of the 21st century was due to an API vulnerability. Gartner's estimating by 2022, so this is only a couple years out, API abuse will be the most frequent attack vector, resulting in data breaches for enterprise web applications. So with thousands of breaches last year, and keep in mind outside of the EU, with GDPR, they're actually required to report these breaches, but in most of the rest of the world, they're not actually required to report these on their own. So the number is likely an order of magnitude higher than this. So it really boils down to the fact that you can't secure what you can't see. So let's just take a quick poll. Raise your hand. How many people are using APIs in their environment today? Okay, everybody. So keep your hands up. How many are using an API management platform? About half of those. And how many feel like they have the proper visibility into their APIs? 3, 4. Okay. So we did a poll on this a couple weeks ago, and an overwhelming majority felt like they did not have the proper visibility. And having visibility into what risk exists and what has changed is the first step. And generally, how well are your services performing, and what threats exist, what insider threats exist, what anomalies are you seeing in your traffic? These are all critical aspects to a successful API program. And every API doesn't face the same challenges, but having that visibility into rates of attacks and latency of responses, understanding how your backend infrastructure is architected to better educate teams on how to respond, will put you in a better position if something does happen in the future. So Appaji is taking a two-pronged approach to visibility. We're offering insights to meet the needs of both operations and security teams. So Today, users are expecting 100% availability. We talk about 5 nines. The expectation is 100%. And Google research from a couple years ago, more than 53% of users will close a mobile app or leave a web page if it takes more than 3 seconds to load. So the bar is quite high. And you need to be able to identify issues before your customers do. And as you can see, Appaji is offering clear insights into where requests are coming from, what latency exists by region. You can generate custom reports. And it's always better to be alerted of issues before your customers alert you. So you don't want to learn about something saying, hey, why did the app installs drop this week, or web traffic drop, or why is support having more customer escalations? You want to be notified before that. And for many of our customers, security issues are initially detected as operational issues. So maybe a large spike in traffic is a good thing. Maybe tickets for an event went on sale, or it's a flash sale or something like that. But if it isn't, this is likely of concern and something you should know about. Appaji gives you the ability to take action based on contextual alerts and before your customers are impacted. So by having access to this data and leveraging Appaji fault codes, you can easily isolate problems and speed up the diagnosis quickly. So from an API security reporting perspective, Appaji has all of the data that security admins need across various parts of our platform. And we've been seeing an increasing trend of collaboration between ops and security teams working together to investigate and track down issues. So we wanted to make this information easily accessible with an at-a-glance view so you can quickly know if there's something to be concerned about. And we announced this on Tuesday, but we are excited that we are now offering the API security reporting in both a dashboard and an API, so you can easily integrate with existing SIM tools that you're using today, existing processes that you already have in place, or in the Appaji Edge console as a security dashboard. And this is going to give you everything from changes in traffic, day to day, week over week. You can break this down in different time periods, get information about change management and governance data, certificate information, policy configuration data on a per API, per proxy basis, information about your policies. So there is more than 50 elements that are going to be included as part of this dashboard, and this is now available in alpha today and will be available more broadly later this quarter. So if we look back at all the recent data breaches I mentioned, if these organizations had a clear view into this data, security and ops data, there would be many red flags that would have jumped out long before an external researcher discovered that. And so I'm going to hand things off to Joel, and he's going to talk more about how API, how the security of your infrastructure is mission critical to your APIs. Thank you.
Thanks, Matt. And thank you all for coming. It's really early, and this is a wonderful conference. I hope you're having fun. So many great sessions, and we're really glad that you chose to come and hang out with us. We hope you'll find this content useful. Just by way of introduction, my name is Joel Disa. I've been working for the last 12+ years on enterprise security problems. And APIs are a key part of your enterprise's IT infrastructure. And I thought I'd spend some time providing a perspective of where API security is today, and perhaps provide some guidance for where the future is headed. Now, security is a very broad field. There are a lot of things to consider, many things to think about. And you could try to wrestle with all of them at the same time, but it's pretty difficult. So what we have found is that if you use data and analytics to understand the threats that are unique to your APIs and to your environment, this will give you more control, and you will be in a better position to tailor responses to those threats. Right? And once you have all the data and metrics laid out, you will find that APIs face threats that are very similar to typical software applications as well as web apps. Right? So you will find everything from basic software issues, things like authorization problems that were faced by Equifax and USPS, or maybe something like a random number generator in your environment that is not really random. Or perhaps improper password storage. This is something that LinkedIn faced in the past, and more recently, Facebook, right? In addition, just like traditional web applications, APIs are also subject to injection threats like cross-site scripting, SQL injection, remote code execution, and a whole host of others. Then there are service availability issues. These are denial of service issues. These can be caused by malicious actors or just some new release of an app that's spiking your traffic, right? But it could cause a service availability problem for your APIs. And then there's a growing risk from insiders, right? A ton of banks, technology companies, payment gateways, insurance providers have been compromised by insider threats. And so we'll talk a little bit about them today. And last but not the least, spam and abuse. Now, if you're following social networks recently and the security issues that they're facing a ton of spam and abuse, and you will see the same thing with APIs today. And we'll cover some of that. Now, the first thing you want to get right is your basic software architecture. And this is something no one wants to address because it's difficult. But it's actually very important and key to your enterprise's security. So things like good code, code reviews, having good tests. This will allow you to reproduce security issues in your environment, fix them, and roll them into production quickly. Then we found security reviews to be helpful. Just having a review ensures that security defects found in one part of your API program don't surface in another part of your API program. And now a lot of developers today, unlike a few years earlier, you just had Java and C#. Today, there's a whole host of software development stacks, right? You can use Node and Rails and Go and Rust, and you should use the tool that's best suited for your problem. But you must go in with your eyes open. Every stack has its own unique security challenges, its own third-party vulnerability management process. The dependencies differ. And so you must go in with your eyes open. Be prepared to address the security threats that your stack poses to you, right? And be aware that they exist, and be prepared to roll them into production quickly. Now, a lot of security defects are found by well-meaning users and customers of your APIs, right? So have a place for them to reach out to you, to send you an email about the problem they're seeing. Build a process to ensure that you're able to triage these issues, fix them, roll them into production, and then get back to the original person who filed it so that they can try it out again and make sure that the problem is truly fixed. Also, engaging a third-party penetration test is actually very useful. And that will help you illuminate any blind spots in your API security posture. And last but not the least, another thing that developers hate is a change management process, ensuring that you have clear visibility into the changes happening into your software infrastructure, who's making them, why are they making them, what is the real change, and who approved it. Is someone even looking into this, or just random changes happening? It's also really important. Now, all of us have to deal with legacy software and tools. And so what I found useful, and you can use that too, is to draw a threat model, something like the picture here. You could use a sophisticated tool to do this, or you could just draw a simple block diagram of your infrastructure, lay out the different pieces, and just draw out the different dependencies. And this will allow you to do an analysis of what exactly exists in your infrastructure, where are the real vulnerabilities, and allows you to measure every component on each of these parameters and stack rank them so you can get a handle on this aspect of your security. Now, all of this information, or at least some parts of it, will be available in the security dashboard that Matt talked about. And so you can start from there and continue to build south. So let's start. One of the most commonly overlooked but easy to implement changes is actually just input validation. Input validation is one of the best defenses against injection attacks, like SQL injection, cross-site scripting, remote code execution. And it's very easy to build. Now, APIs, unlike traditional web applications, have an open API specification or a Swagger spec. So there's well-defined input and output. So it's very easy to identify all these inputs, categorize them, and just deploy uniform input validation. Now, there are two things to think about. One is consistency, and two is the use of shared libraries. I'll just talk about them with an example. Take a look at this hotel, right? There are all these rooms, and all these rooms have the same looking door, right? Now, suppose the doors were different, right? And some of them had these push handles, and other handles were these rotatory types, and then there was another kind of like handle that you could open the door with. And an attacker walked in, and they would look at all these differences. The first thing they would do is go and try every single door to try and find any inconsistency that they could break through. Right? So having a consistent input validation and layer in front of your APIs is actually very powerful. And we're seeing this with our APIs as well. Appaji hosts enterprise APIs for a ton of customers. And the customers that have sort of inconsistent input validation or respond slightly differently every single time actually get scanned the most. Now, the other thing is, one of the ways to achieve consistency is to deploy shared libraries. So take a look at this example. In this specification here, name, tag, and status are all strings. Right? So explore the opportunity to see if you can use the same regular expression and maybe even the same length just to achieve consistency. Use a shared library. If you use a shared library, sometimes regular expressions are hard to write. If you fix it in one place, your entire platform will benefit. So it is something you should at least check out, try it out, and we've used it successfully. API management vendors like Appaji provide a whole host of policies that allow you to easily deploy input validation. Now, if someone is scanning your API and these policies trip, all that information will show up on your security dashboard. So you can get a clear understanding of who is attacking your API. Working mobile apps and well-meaning partners don't trip your input validation policy. It's the rest of the people trying to actually break in. So you will get a better idea of what's going on. Now, one of the most common questions that we get from customers is how do you deal with service availability issues or DDoS type situations, right? These are very easy to create. APIs are out there. The specification is known. So anybody can try to maybe cause a brownout. It could also be caused by buggy clients or maybe partners that have misconfigured their applications and are causing availability threats. And the best way to defend against API availability issues and DDoS type situations is to actually scale out. And the reason that is the case is that if your infrastructure is able to successfully defend against a denial of service attack, all the attacker needs to do is just ramp up the traffic, right? So you need to scale out. Now, this problem is not new for Google. Google has been defending its infrastructure for years against denials of service attacks. So there are a whole host of tools that Google offers that you can use. If you use Google's cloud load balancers, these are the same load balancers that protect Gmail. They scale very effectively and are able to defend against layer 3 and below type attacks. In addition, you will find that Google's network is one seamless global network. It scales to handle all of Google's traffic and can handle yours as well. It is equipped with multiple layers of load balancers that are all denial of service aware. So if an incoming denial of service attack is sensed, these load balancers can drop traffic before it hits your backend. And the goal of any successful denial of service attack is to actually protect the backend. Make sure that your API backend does not have to deal with any junk or unwanted traffic. Now, to deal with API-level availability issues, you can deploy some policies from Appaji. Appaji's API management provides policies like API rate limits. This will allow you to smooth any spikes in your traffic. In addition, if you deploy Appaji's globally distributed and encrypted caches, these will help save your API backend by serving up responses to frequent requests. And in addition, if you use resource quotas, this will allow you to deploy quotas on a app or client or partner base. And so you can do on a resource-by-resource level, defend your APIs against too much use. Now, the next thing I wanted to point out that any of these threats that face your APIs will show up in your security dashboard, so you can get a better understanding of which APIs are subject to such kinds of threats. But one of the most important things that you could do to defend your APIs against security threats is actually to protect the user of those APIs. And sometimes this is a hard thing to do, and many people get it wrong. And I was hoping to spend some time on this topic, starting with a history, because the space has undergone a series of changes. I thought I'll take you through a history of those changes, give you a perspective of where I was coming from, and then provide some direction for where the future is headed. So let's start from the mid-1990s. Most websites were, in the beginning of the internet, were really simple, right? And even today, most government websites that just provide information, if any of you filed your taxes recently and went to the IRS website, you'll find it something like this. It's a rather monolithic website. Most of the content is served from a content management system or a simple database, and all of this infrastructure and code is protected using a network perimeter, right? So it's very simple. But as the internet became more complicated and websites started getting more complex, multiple websites were deployed to the same container. And data tiers were deployed to these containers that allowed these websites to accept user input. And the first user input, obviously, was user credentials. Usernames and passwords were exchanged for cookies. And again, an infrastructure like this was protected using a network perimeter. Now, as these got even more complicated, reusable data components started getting deployed to the same container. And in order for this infrastructure to scale, multiple pods of the same kind of layout were deployed on a worldwide basis. And there was a concept of sticky sessions, right? They're still available today. Sticky sessions ensure that once you authenticate to a single pod of the infrastructure, load balancers will make sure that all subsequent traffic from your browser will hit that same pod of infrastructure. And then if those of you who have worked on WebSphere and WebLogic will recognize this, where session EJBs were deployed to application servers, and that allowed the data tier to scale independently of the web tier. Now, mobile apps and stateless UIs using AJAX, I don't know if you remember that, that is when things started to shift a little bit. Right? So if you went to an airline website in the mid-2000s and they were rolling out a mobile interface, you would see this shift. When you went to book a flight, you would see this wonderful fluid experience. You would see all the prices laid out dynamically in a table. You could select the dates and you book a flight and everything was great. And then you went to check flight status, right? And that was an older experience. You had to hit next, and it was rather painful. And this was the transition everyone was making. But one aspect was the jarring customer experience. What was even more jarring was the authentication and authorization infrastructure deployed to support such a kind of an app, right? So modern stateless UIs, including mobile apps, use API gateways, APIs, tokens, whereas traditional web applications continue to use cookies, right? And this difference is what I wanted to call out. Now, what you'll notice is throughout this evolution, the underlying security model hadn't really changed. All the data and logic required to make security decisions was constrained to that same network perimeter. In many cases, it never even left the JVM. And this is starting to shift. This sort of an architecture no longer makes sense. And there was a reliance on that network perimeter. And perimeters are good, right? They give you peace of mind. If you look at this castle here, it looks great. I would stay in a castle like that. You'd be very secure. It gives you total peace of mind. It enforces consistency. It limits the damage of a breach. If that castle was to blow up, none of the town around it would ever even feel it. And it limits the number of attacks because it looks secure. So there's nothing wrong with this, but there are a few things you want to notice about this now. 50% of our customers are moving to using microservices. One thing you want to notice about microservices is that in traditional web applications, the applications were deployed to application servers, right? But with microservices, and especially if you use something like Spring Boot, it's the server that's deployed to the application. So it's actually the other way around. So whereas in an earlier architecture, if you used an application server, the application server handled authentication, authorization, session management. But with microservices, there is a need for consistency because it is now the role of each microservice to take on that load. And if you have thousands of microservices all deployed to Kubernetes clusters on a worldwide basis to multiple clouds, how do you even draw a parameter? And this is a really big challenge. So what you want to do is to use an API gateway to limit the aperture of what you're exposing and pair it with an identity management solution to use identity to manage the relationships between internal service producers and external service consumers. You might also choose to deploy a service mesh that will allow you to compose applications of your different microservices. And as I said earlier, deploy an API gateway to expose only what's required. You also want to pair this with a highly scalable, highly secure identity management solution. Now, if you choose to use Google's identity management platform, this will allow you to deploy a standard, consistent authentication and authorization layer, right? It will use standards-based frameworks like OAuth 2. And it will also prevent fraud and abuse, because this is the same infrastructure that defends Google. The systems will detect users that are malicious, that are trying to break in, that are trying to do credential stuffing by reusing passwords, and will defend against a whole host of attacks. In addition, and you should notice the trend now, the metrics generated by this will tell you who is attacking your platform and what are your users actually trying to do. Are they legitimate or not? So this is something we highly recommend everybody do. Now, let me talk about another remnant of the old cookie-based design, right? So it was a design that looked like this. A client would typically take user credentials and forward them onto a service. The service would then forward them on to an authentication server to check if the user was valid. It would then check with an authorization server to ensure that the user really had the right level of access. It's a very common design pattern, nothing wrong with it. Now, but as these services start to grow, you will see increasing load on the authentication and authorization servers. Even the slightest latency at that layer will present a huge latency problem for your entire infrastructure. In addition, they are single points of failure. And one breach, say in service 1, will actually compromise your entire infrastructure because the system does not allow for time-bound delegated access to data, right? So service 1 has access to all the credentials. If that is compromised and that service is hosted, the entire infrastructure is gone. So what we would recommend is that everyone move to something that looks like this. It's very similar, but there is more onus put on the client. So your client will now exchange credentials for an OpenID Connect identity token with an OpenID Connect server, right? So the OpenID Connect server will authenticate the user. Then it will exchange the identity token for an access token. And the access token, if you use something like OAuth 2, will give you time-bound delegated access only to service 1. Now, if you use a JOT token, JOT tokens are very common nowadays, but they're basically just encoded, base64 encoded blobs of data that are signed by the server, right? So all the service needs to do is just open up the token and validate the signature. And now in every request, you have all the information required from a security perspective to complete the request. So the service does not have to make any outbound calls to do anything. So JOT tokens will help your service scale better. OAuth 2 will give you a consistent authentication and authorization experience, and will provide you a framework to implement time-bound delegated access to data, and that will limit the breaches. And then, from a traditional architecture point of view, this is what is called as sort of zero trust, right? Authenticate everyone, every time, all the time, right? So that's what you might hear commonly as zero trust. So it is a way forward to implement a zero trust architecture. Now, one of the things a lot of security folks have to pay attention to is the user experience, because that's where everything will break, right? So if you deploy this wonderful security and you mess up the user experience, that's where you'll see a breach. So this is an example we were working with a retail customer, right? So retailers have a whole host of partners that they work with to be successful. And so in this particular case, the partner reached out to the API team and said, hey, I want to access this API. And the API team was super excited, and so they contacted the security team to get a key issued. And now the security team does not have any context on this, so they're trying to figure out the right scope of access. So they try to create the right rules, and they mint the key, and they hope it's right. And now they have to send the key over. So they would encrypt it using their PGP key, and then send it to a manager who would do the same thing. And they would transfer that to the app developer, who would then use an out-of-bound channel, maybe call them up and figure out what the key was, and then finally it would work until it was time to change the scope of access. And then the entire process would have to be re-rolled, or they had to unload the partner, revoke their access, and then again, there was a mess. So a lot of our customers use what's called a developer portal, right? A developer portal gives API consumers a self-service experience so that they can go and check out the APIs, understand what is available for access and what is not, so that they don't request the wrong access. In this case, Mercedes-Benz, you should check out their developer portal. They've done a fantastic job, right? So the developer portal explains all the APIs that are available, what they can do, allows the developer to try it out, and then allows the user to register for a key. And you can then build an approval workflow on the back end that will allow the right people to look at the request, make sure it's valid, and have a key automated, securely delivered to the API team. Now again, one more thing you want to call out here is that all the information from this developer portal will be made available in the security dashboard. And so you can get a better idea of who is accessing your API. Is it valid or invalid? Is it malicious or not? Is someone poking around your developer portal just for the fun of it? Has that same user breached another part of your website? So that's actually a great way to get awareness into what's happening with your API program. Great. Can I have a show of hands for how many of you are concerned about insider threats? Wow. We did the session on Tuesday, and this is a much bigger audience and a much better show of hands. Insider threats are actually a commonly overlooked problem, but a huge problem for a lot of enterprises. There are a ton of privileged users that have access to lots of data, and maybe they shouldn't have. If they do, maybe they shouldn't use it unilaterally. They should have someone else provide some sort of approval. And they're an increasing problem for enterprise security. Time-bound delegated access does not only apply to API authentication. It also applies to your employees and their contractors and anyone with access to your API program. So what you want to do is, the first thing is integrate your API management solution as well as your Google Cloud Platform with your enterprise's single sign-on infrastructure. And that's a great first start. It allows you to provide a consistent way of looking at who is doing what in your infrastructure. What are they trying to do? Like, are they doing something malicious, or are they poking around where they shouldn't be? Things of that nature. And then the same things you use to protect your webmail, like two-factor authentication, or what have you, risk-based authentication, you can use the same way to protect your API platform. Now, the second thing you want to do is to deploy change management. That is to understand who is making what changes to your APIs? What are the changes? Why are they being made? Is there some sort of a design? Is there some sort of an approval? So there's some governance and visibility into what's happening to your API program. And again, we hope to provide some of this information in the security dashboard. It will give you a good view of the changes happening to your APIs. And so you can get a better idea when you integrate it with your other tools. You'll get a holistic view of the changes happening to your infrastructure and whether there is some visibility into it. And last but not the least, I wanted to talk about spam and abuse. Now again, we host a ton of enterprise APIs. Many of our retailers are very, very concerned about Black Friday. And we see a lot of spam and abuse, especially on high traffic events. And this is everything from credential stuffing, people just trying to brute force the API, or just content scraping. For a retailer, the price matching is a very big deal. So you might just want to content scrape to figure out what's going on. And so there are a whole host of automated actors who are trying to break open the API. There are automated bots that are constantly scanning these APIs for any changes. Now, obviously, abuse and bots and denial of service are not new problems to Google. And we are bringing the best of Google to help you deal with this. So there are two broad solutions to spam and abuse defense. One is a prevention system that you can deploy. And the other is a visibility system that will allow you to get better visibility into your APIs. So from a prevention point of view, your goal is to put maximum onus on the client to prove who they say they are. One of the best ways, again, is to authenticate the users and the clients. But we recognize that a lot of APIs today don't need to be authenticated. Or maybe authentication is too high of a barrier. So what you can do is deploy a system like reCAPTCHA. reCAPTCHA, I don't know if you've noticed it on many websites. It's a simple box with a checkbox, and then it shows up a challenge. And the challenge then slows down the user. They have to actually do something. And so it slows down the rate of spam and abuse, because automated bots can't solve that challenge in many cases. But last year, if you don't want that kind of a disruptive user experience, pick out a goat from this map, you might want to deploy version 3, which was launched last year. You should definitely check it out. Version 3 gives you a reputation score. And that will allow you to make a ton of access decisions based on the reputation score. And yesterday, that same team launched what's called reCAPTCHA Enterprise with a whole host of enterprise-ready features. And this, if you deploy, will give you a much better idea into spam and abuse and allow you to take control of it. Now, the second thing you want to do is gain visibility. Google has a product called Cloud Armor. If you deploy this in front of your APIs, you will get a better view into the metadata surrounding your API accesses. What are the IP addresses? Where are they coming from? What locations? Can they be blocked? Do they have other history? So you will get a better idea of what is actually hitting your API endpoints. In addition, Appaji has a product called Appaji Sense that does analytics on your APIs that will allow you to tell you whether this is a credential stuffing attack, someone trying to brute force or content scrape, and will classify the different kinds of attacks, and you can get a better idea of what's going on. So we covered a lot of content today. I hope it was useful. So I hope it is also clear that using a data and metrics-driven approach is actually mission critical to improving your API security. And in addition, with the ever-expanding world of microservices, APIs, mobile apps, your architecture really needs to change in order to improve your security and keep your users and data safe. Thank you very much.